In this video, in this one, we are going to be finding how to calculate theoretical yield, just like in the former video, but that's little different in this. In this one, we were given different mass of hydrogen and another mass of oxygen. So meaning that before you can actually get the theoretical yield, you need to find out the excess and the limiting reagents. Now remember, like as we have said before in our previous video, we're able to understand that the excess reagent is the S and the reagent that's in excess, and the limiting reagent is the one that determines the end of the reaction because it's the limiting, it's not enough. Most often it's finished before the end of the reaction. So once it finishes, the reaction will stop. Here we are going to be we need to find out the reagent that is the reactant that is in excess, and now the one that is what that is limiting. Now, like we already told you, that theoretical yield has to do with what the the yield expected, that is from the balanced chemical equation, what is expected. But in the real analysis, you find out that when you do the real analysis, you find out that the actual yield is always different from what you have in your theoretical yield. So let's quickly dive into what we have for today. Here the question says that if 10 grams of hydrogen reacts with 112 grams of oxygen to form water, what is the theoretical yield of theoretical yield in grams of water? So the first thing we do here is to find out the one that is limiting. So by looking at this, we have 112 grams of oxygen, 112 grams of oxygen, mass of oxygen, that is mass of oxygen is equal to 112 grams, and then mass of hydrogen is equal to what? 10 grams. So to do this, in order to find this limiting reagent and the excess reagent here or reactant, you find out that the one that gives us less products, the one that gives us less products is likely to be the limiting. That means that one is likely to finish before the other one. So that one that will finish first is the one we know as what? Limiting reagent. So by so doing, now let's find out how many mass of oxygen that will combine with excess hydrogen to produce water. So from here now, we are dealing with the mass of oxygen, oxygen and what? Water. In that case, we know from this balanced chemical equation, you will find out that 32 grams of oxygen will give us 36 grams of water. So one might wonder, how do I get this? You know that molar mass of oxygen, relative atomic mass of oxygen is 16. 16 times 2 will give us 32. And then water is 18. 18 times 2, from the equation we have it to be 36. 2 multiplied 18 will give us 36. So, but what we have here, what we have in the oxygen, in the given mass is what? 112 grams of oxygen. So what are we going to get if we use 112 grams of oxygen? That will be 36 over 32 multiplied by 112 grams. So by doing this, what we are going to get will be, let's see what we have. 36 multiplied 112 divided by 32. What we have here is, we have 126 grams of what? Water. That is what we have. So let's see, this seems to be a bit bigger. So let's see what we have if we are using 10 grams of hydrogen. Now, from the balanced chemical equation, we are meant to understand that 4 grams of hydrogen will give us, reacting with excess of hydrogen, that will give us 36 grams of water. Then that means 4 grams of hydrogen will give us 36 grams of water. So 10 grams of hydrogen will then be 36 over 4 multiplied by 10. When we do this, we're likely to get 90 grams. So based on this, now you find out that the one that is reacting in excess happen to be oxygen. Then the limiting reagent is what? Hydrogen. So with this, now we will be able to work on getting the theoretical yield of water that we're likely to produce in grams in this reaction. So let's quickly go down to that. Since now we know that the limiting reagent is hydrogen, that means it's hydrogen that will finish before the end of the reaction, and that determines the end of it. That determines the end of the reaction that we are going to carry out. So in that case, we know that from this, we have 10 grams. Before we do this, I'm going to solve it in 2 ways. Before we do this, we divide it, we convert it to what? We convert it to moles. We have moles, and we know that, okay, we know that moles is equal to mass over molar mass. Now we have the mass. We have our mass to be, our mass there is 10 grams, and then the molar mass of hydrogen is 2. That will cancel. We have 5 moles. Now, relating it to what we have in the chemical equation, we find out that 2 moles of hydrogen will produce 2 moles of water. 2 moles of water. So then 5 moles of hydrogen will then give us 2. Okay, it's going to be the same. It's going to be the same because that will be 5 moles too. So what we do now, we have from the mole ratio, we find out that 2 moles of hydrogen will give us 2 moles of water. That means 5 moles of hydrogen will also give us 5 moles of water. Now, we know that moles, since we are looking for mass, theoretical mass, and theoretical yield in grams, that is mass. So what we do now is that, knowing that mole is always mass over what? Molar mass. So if it's so, we have our moles to be 5 moles. Our mass is what we don't know, and then the molar mass of water is 18. So what we do now, multiply through, we have mass. Our mass will be equal to 5 times 18. That will give us, that should be 90. Let me check. 18 times 5. That will give us 90 grams. 90 grams of hydrogen. 90 grams of hydrogen. Now, the next method we're going to be using to solve this problem, we can also work straight mass to mass stoichiometry of this chemical reaction. Looking at it mass to mass, if you are going to be using this relationship, it means that we have the total mass here is mole times what? Molar mass. Now the molar mass of hydrogen is 2. Number of moles there is 2. That will give us 4. Here also we have mole multiplying mass. Here is 2. Multiply 18. We have 36 grams. So what it simply means in this balanced chemical equation, it means that 4 grams of hydrogen will give us 36 grams of, water. So 10 grams of hydrogen will then give us 36 over 4 multiplied by 10. So what we still have after everything will still be about 90 grams. That's 90 grams. So that's what we have. Thank you so much for being part of the class. If you're joining for the first time, we encourage you to subscribe. If you have any question, you can leave your question in the comment section. And make sure you share and like. Thank you so much.